In this video, we're going to be solving Leetcode problem number 1, two-sum. This is listed as an easy problem, also listed as the first Leetcode problem. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that the input would have exactly one solution, and you may not use the same element twice. You could return the answer in any order. So here we're given an array of 4 integers and a target of 9, and we're supposed to see which two integers add up to 9 and return their indexes. So you can see 2 and 7 add up to 9, and so the answer is 0 and 1, index 0 of 2, index 1 of 7. Here we're given 3, 2, 4 and a target of 6. If you do the math, 2 and 4 add up to 6. It's the only answer. You return 1, 2. This can also be returned as 2, 1 if you wanted. Here there's only one answer, one option, 0, 1. Okay? The constraints here, as you can see, we can have some very large lists and very large numbers going from negative to positive. So you have to account for that. I'm going to go ahead and code this up in Rust, but because Leetcode doesn't have a very good syntax highlighter and intelligent importer for this ID, I'm going to switch to VS Code. So I've gone ahead and written the basic function signature here. It's the same one as the problem. As you can see, I call it in main, but I don't actually call it with anything. I have down here the tests, and these are the example tests that they have written out. So if I run this now, none of the tests will pass because I haven't coded the solution here. But once I've coded the solution, and if it's correct, these test cases will all pass. All right, so first we're going to need a hash map. So we'll go ahead and create a variable. We'll call this map, and it will be a hash map. And we'll need to import this. So we'll go up here and use std collections hash map. We make this mutable because we will need to add to it in the future. Next, we'll go ahead and iterate through our nums array, and we'll actually want an enumeration or enumerator. So we'll need the index. First thing I'm going to do is, since we're dealing with I32s, I'm going to go ahead and replace I as an I32 because our enumerator gives it as usize. The next thing we'll need is a comp or a comparable number. And what this is we're going to take one of these numbers in the array and we're going to subtract it from our target number, and that will give us a comparable number where 2 plus 2 minus 9, which is 7, is the comparable number, and that's the number that we're looking for in this case. So we'll go ahead and do this. Let comp equal target minus num. Then we'll check if it exists in our hash map. We'll need to borrow it here because contains key wants a borrowed instance of a generic type that gets passed in. This is where we'll return a vector that they want. They want a vector I32s. So this is where we'll return our indexes because we found a comparable number to the one that we're looking at. So we'll go ahead and return here vec. And I'll fill this in a second. And if we don't see a comparable number, we're going to add our number to the hash map. The key here is going to be num, and the value is going to be I. So when we return our vec, we'll return the index that we're currently at, and we'll have to get the index from the comp that we found. This also wants a borrowed comp, and this returns an option. As you can see, this returns an option, so we'll need to call unwrap on it. And we just need to dereference it because it is returning the borrowed instance inside the collection, so we'll dereference it here. All right, let's check if this compiles now. And it compiles fine. We'll go ahead and run our tests. There you go, all tests pass. So I'm going to go ahead and copy this, bring it back to Leetcode, paste it in here, give it some indentation. I'm going to also copy the import statement, and we'll go ahead and run this. And it passed this test case, so we'll submit it. And there you go. An interesting thing, I did write this in Python a few times before, and as you can see, the runtime of Python, 60 milliseconds, using about 15 megabytes of memory, and the Rust version got it down to 0 milliseconds, 2.4, 2.3 megabytes. So a big difference there, two different programming languages. But there you go, there's the solution to this problem, and I'm sure a lot of people have solved this, seeing as it's the first one. It's relatively easy. There is a brute force method where you can compare every single integer against every other integer until you find the target, and that will use actually no space, but its runtime is much longer. This runtime is O of n, so you just make one pass over the array, but it does use the extra space for this collection. But the lookup time of this collection is O of 1, so it doesn't add to the runtime, but it does add to the memory. All right, thanks for watching. Hope you enjoyed.